Hey guys, welcome to the second day of 1.4. Just recapping what we did yesterday, beginning of 1.4, we looked at how to prove a function is continuous. So we said for a function to be continuous at C, the limit as x approaches C has to equal the output at C. Okay, and remember we know for a limit to exist that the left and the right had to meet up. So today we're going to be looking at IVT, the intermediate value theorem. And before I get into it, I want you to notice right here it says if f is continuous. So do you get already, this is drawing in yesterday's information, so we need to have a function continuous. Before I read any more of the theorem, I want to show you why we need continuity. Okay, so let's take this apart. We'll get back to the theorem in a second. Let me just give you a more basic question. So let's say you travel from x equals -1 to x equals 2. Are you guaranteed to pass through x equals 1? Notice I have two number lines down here, so we're going to have two different scenarios. The first one is going to say that we have continuity on -1, 2. Okay, so let's say we're going from -1 to 2. Are we guaranteed to hit everything in here? Sure, if we have continuity, there's no breaks. We're going to hit each one of these values. We're going to hit 0.0004. We're going to hit 1.9. We're going to hit all these values. So are we guaranteed to hit 1? Well, 1 is in this region, so for sure we are. Now, the second situation is going to say, what if we're not continuous on -1, 2? So before I go ahead and draw that, let's say we're looking at this region here. Not continuous means there's going to be a break or a gap somewhere. We don't know where the gap is. If we don't know where the gap is, isn't it possible that the gap is at 1? And if the gap is at 1, will we hit it? No. So we need continuity to show that everything will be hit between the two values. Okay, so let's go ahead and draw this so it doesn't work actually. Let's go from -1. What if the gap was here? Okay, would we be guaranteed to pass through 1? Can you guys clearly see this is no? Right, we're not going to hit 1 because there's a gap there. So in order for IVT to work, we need to prove continuity. All that this is basically saying, IVT, this is what I want you to get out of this, is if I travel from one spot, let's get rid of that. If I travel from one spot to another, I will hit everything in between as long as I have a function that's continuous. If on the right I have a function not continuous, there's a possibility I might not hit the value I want. Okay, so we're trying to prove continuity. Okay, down below, I want you to draw a graph with me. So go ahead, let's draw a first quadrant. We're going to make sense of this. So now we're going to take apart the whole IVT, but at least now you have a sense of what it's saying. I want you to go ahead and draw a function that is going to look like this. And I want you to go back and forth. So go back to the theorem and come back to this picture. Okay, and I'll try to move back and forth as well. Okay, so actually, you know what? Go ahead and read through the theorem up above, and I'll just keep drawing the picture. So f is continuous. So first part of the theorem, do you guys see that we have f is continuous? Okay, I drew a function f that is continuous. Now it says it's continuous on a closed AB. So let's make this A and let's make this B. Notice how I drew it. We had no gap, so we have continuity. So far we're meeting every condition in the theorem. F is continuous on a closed AB. Now one thing to note we're going to do this year is if I know that this value right here is A, and I know I'm on the function f, do you guys get that the output then has to be f of a? And likewise, this output, if we follow it across, will be f of b. The next part of the theorem says that k is any number between f of a and f of b. Okay, so if k is any number between f of a and f of b, then k is going to be anything between these. It doesn't matter where we pick. I'm just going to pick a random value here. Let's call this k. That's f of b. That's f of a and f of b. So going back up to the theorem now, it says if k is any number between f of a and f of b. So I want you guys to notice we needed two conditions. We need f to be continuous, and we need k sandwiched between those. Then it says there's at least one number c on AB. So we have at least one number C on AB such that when you sub C into the function, you get K out. Okay, so we're going to go a little backwards here. When you sub C into the function, you get K out. Well, here's K, so this must be a C. Here's another one, and here's another one. Now to differentiate between these, how about we call these C1, C2, and C3? Okay, so the theorem says if we have F is continuous, K is between F of A and F of B, then there will be a C that produces that K. All that this is saying is if I'm going from right here to right here, all these functions in between, I'm gonna hit. As long as K, which is what we're looking for, and whatever the problem is in between F of A and F of B, then IVT says that the point exists. Okay, so let me walk you through an example now how to address this in a real problem. What I want you to get out of this is the conditions. We need F to be continuous. We need K between F of A and F of B. Then we can say there's a C that produces that. Okay, if I'm going from point A to point B, I'm going to hit everything in between as long as the function's continuous. Okay, let's look at the first example. If you measure the outdoor temp on your back porch to be 47 degrees one morning at 8:15, how about we start recording some of this data? So at 8:15, we measure the temperature and it's 47 degrees. We then measure 4 hours later, so now 12:15, and it's 62. Explain why there must be a time between those two times where the temp on the back porch had to be 51.351. That's pretty exact. Okay, so let's look at the first question here. So the first question just said, explain why there must be a time between these two where their temperature was this. Okay, so looking at our times, how I want you to think of it is, do you guys see that this is kind of like your A and your B? Right, so we're looking at these saying I start at 8:15, it's 47, and at 12:15, it's 62. Imagine a thermometer. I'm really not going to draw a nice one, okay? But if this is 47 and it goes up to 62, in order for the temperature to rise right here, doesn't it have to eventually go through all these numbers in between? So again, forgetting that you're in math class, is the 51.351 in between the two outputs? And can't you see that it is? Okay, so the common sense aspect says, yes, we're going to hit 51.351, but let's now take it apart with IVT and write out an awesome answer. It says in the first part, F is continuous. Do we have continuity? Well, they didn't really give us a function. This is more of an idea, but don't we know temperature is continuous. So we can say since temperature is continuous, and now what's the next case? Go back up and look at your theorem. It says we need F to be continuous, and we need K to be between the two outputs. Well, what's our K right here? Our K is 51.351, and isn't that number between the other ones, which are 47 and 62? Okay, so again, I want to make sure we get all these conditions met. We need continuity. It's if this and this, then. Okay, now we can go prove what we want. So since we have continuity and the 51 is sandwiched between the 47 and the 62, we can say by the intermediate value theorem, by the IVT, there must be a time between 8:15 a.m. and 12:15 p.m. when the temperature was 51.351 Fahrenheit. That's what that is. Okay. So notice what IVT told us. It only told us, well, the first question, it's underlined in orange, says explain why there must be a time between 8:15 and 12:15, where the temperature was 51.351. I'm going to advise when you go to write these sentences describing your answer is that you use the theorem. Like I went to when I went through this with you. We had to show we have continuity. We had to show that K was between f of A and f of B. Then we can say, by the IVT, this must exist. Notice I use the word exist. All I'm saying is, yes, we will hit this. Notice what we cannot conclude. Look at the next question. It says, is there a time or is there a way to determine the time the temperature was that? And no, I'm running out of space down here. I'll write it right here. But no to the second part. We can't find a time when it happened. All we're saying is that it exists. Okay, so down here I give you a little note about that. Theorems like the IVT, they're actually called existence theorems. That's how I would describe them, because they don't tell us like how to find when it happens. It just says that it will happen. Like the analogy I gave you up here, right? My only question to you was, will we hit 1? And it's just yes or no. Okay, it's not telling us when or where. Okay, let's look at a couple more. Okay, on to example 2. In this case, we have a car traveling on a straight track, and during the time interval 0 to 60, you see I already have an A and B there. I want to keep relating this to the theorem, because if you know the theorem, you'll know how to approach these problems. Okay, we have a car's velocity, continuous. Remember, that was the first thing we needed. We needed to show that a function was continuous. So we have that out of the way. Okay, and then the table shows selected values of the function. For t between 0 and 60, must there be a time when velocity is -5? A couple minutes ago, I just said a lot of times the way we answer these are like yes or no. It's not saying when the velocity will be -5, it's just saying will it? Well, look at the data. So before we even do the math with this, look at the data here. Velocity goes from -20 to -30, -20, -14, -10, 0, 10. If I was to look at this, is -5 between those numbers? Sure. What's the lowest? -30? What's the highest? 10. If I'm going between -30 and 10, isn't it -5 somewhere in here? Okay, so because of that, we already know how we're going to answer this. Yes, now we just have to have some mathematical proof. Okay, so the first thing we're going to say is, let's look. What's velocity of 0? It's -20. So I'm looking up here at this time interval. And what's velocity at 60? We have 10. So -20 to 10, is -5 in there? Yes. Okay, again, if I'm relating it to here, at the last problem we did, I was saying if I go from 47 to 62, will I hit 51? Now I'm saying if I go from -20 to 10, will I hit -5? Okay, and the reason I chose those is we're looking at f of A and f of B. Okay, what's the first part of the theorem? We're going to go back up and look at this. It says if f is continuous and K is between f of A and f of B. So we need to say, yes, we have that condition. So we're going to say since V is continuous. So sometimes I make the mistake, I'm so used to using f, I forget to use the function I'm dealing with. So double check on these problems. We're talking about V. So since V is continuous, and remember we wanted K between f of A and f of B, this is our K, the -5. So then we can say, and -5 is between -20 and 10. So the -20 and the 10, was that V of 60? Yeah. By the IVT, there exists, and again, relating up here, look at how much this matches up. We have continuity, we have K between those two. Then it's saying there is a C in the interval such that f of C is K. So that's what we have to state now. So we could say there's a value C. And remember, C has to be in the interval between 0 and 60, because it said there's a C in AB. And remember, this is our A right here, and this is our B. So there is a C between AB, such that, and remember it said f of C is K. Okay, but ours is going to be V of C, and what was our K? It was -5. Okay, so again, I really advise that you memorize the theorem. We're going to use it a lot this year, and then you really use the theorem to write your sentence out. Okay, the big thing, we need continuity. Look back up here. We need continuity and K between f of A and f of B. Okay, let's look at the next one. Can IVT be applied to this? So no context here. I'm just giving you a function. So looking at this function here, do you guys notice anything? Right, I'm mentioning when you look at function, notice the domain restriction. Do you guys see x can't be 1? Function's not continuous at 1. So if we don't have continuity, can IVT be applied? Well, what did it say? It just said that f had to be continuous on a closed interval. Look at, they gave you the closed interval right here. Do you notice what this doesn't include? It doesn't include 1. So is f continuous between 2.5 and 4? Sure is, just not at 1. So all we can say here is, can the IVT be applied? Remember, a lot of these are yes or no. Yes. F does not exist when x equals 1. However, here's the good news. X equals 1 is not in the given domain. Okay, going on to the next one. Does this function have to have a 0 in it? Okay, so it's saying, do we have to have 0? Does f have to be 0? So to have a 0, remember that's when the function equals 0. So it's saying, does f have to be 0? Well, is f continuous? Yes, so we have that first piece. Then we need, remember on the second part of IVT, you need K to be between f of A and f of B. Well, here's your A and here's your B. So we need to find out what f of A and f of B is. So f of A is actually f of 0. Let's fix that. We don't want to write an A in there. So f of A, oh, did it again. Sorry, guys. So f of 0 is 0 squared minus 6 times 0 plus 8, which is 8. F of B, which is f of 3, is 3 squared minus 6 times 3 plus 8. And that's going to give us -1. So we found our f of A and f of B. They're looking for this, that's saying, will the function hit 0, which is the K value? So is 0 between -1 and 8? Sure. So now we can start our sentence. And I want you to look at how similar this is to the sentence that we wrote in example 2. So since we're dealing with f here, so since f is continuous, okay, and f is continuous everywhere. If we want to say, because the theorem says on AB, we can go ahead and write that if we want. We could have also just left it because f is continuous everywhere. So since f is continuous and 0, remember K is between f of A and f of B. K is between these values, the -1 and the 8. By the IVT, there exists a value C. Again, same thing that we were writing. And remember, C had to be between A and B. So C is between A and B, such that f of C is K. F of C, in this case, our K is 0. Okay, if you have the theorem right next to you, you can see how much this matches up. Now they asked us, so this is all IVT does, right? We explained why, we're good, but now they asked one more thing. They said, if so, can you find the value? Now we weren't able to up here. Up here we were looking at it, and we said, can the velocity ever be -5? Sure. We said yes. There is a value C where velocity will be -5. They didn't ask us when that will happen. Like, they didn't ask us for a time when that would be happen, and even if they did, we couldn't answer it. However, on this problem, they gave us a function. So they're saying, can you find out when this value, the C that makes the value 0? So let's go ahead and do this. Let's take f and set it equal to 0. Do you guys see that this factors? And you get 2 answers. You get 2 and x equals 4. Now, if you stop right here and say, hey, I have it, this is the right answer, you made a mistake. Because remember, we're looking at a restricted domain here of 0, 3. So we can only be between 0 and 3. Do you guys see that 4 is not between 0 and 3? So our answer would just be x is 2. okay, because 4 is not in the domain. Okay, going on, you guys, these are a lot shorter than normal. Hopefully, I think this is the last page. Okay, here's another one. We have f and g are continuous. I hope you're starting to see some patterns in IVT. We deal with continuity a lot. It says the table below gives values of the functions that select values of x. H is this composite function here. Explain why there must be a value r. So if I'm relating this to what I know, right away I'm thinking IVT because I know I have continuity. This is like our C. Our C is between A and B. I'm just trying to relate this to what we did, such that h of c is -5. And do you see that that did not mean the negative there? Do you see that this is like our k? Okay, so this is similar to what we were doing before when we're looking at IVT. So the question is saying, will we ever reach a -5? Again, it's going to be a yes or no answer. First, before I find if I'm going to hit -5, I have to find f of a and f of b. In this case, it's h of a and h of b. So the interval right here goes from 1 to 3. So I need to find h of 1 and h of 3. H of 1, they told us over here what h is. So I'm going to replace x with 1. So it's f of g of 1 minus 6. Remember, with composite functions, you work inside out. So this g of 1 right here, I'm going to go over here. Here's g. I'm going to go over where 1 is, and that value is 2. And then now I need to find f of 2. So here's 2, here's f, and I get 9. So it's 3. So h of 1 is 3. Now I need to find h of 3. That's f of g of 3. G of 3, I go to the table again. Here's 3, here's g. You can see they match up at 4. F of 4. Here's 4 and here's f. Here's -1. So -1 minus 6. Oops. So -1 minus 6 is -7. Okay, so I have h of 1. And then I have, let's rewrite this. I just want to be able to circle it. And okay, so h of 3 is -7. Okay, so now I'm dealing with h of 1 and h of 3. The question was, again, is h of r -5? Is it -5 between 3 and -7? So our answer is yes. So let's write our sentence out now. Since, again, hopefully you have this down. Try not looking at previous examples and see if you can get this sentence down. So since h is continuous, looks like his, I guess put a space in there. Since h is continuous, and what did they want? -5 is between h of 3 and h of 1 by the intermediate value theorem. There exists. Now, normally we say there exists a C. They called it R this time. So they exist a value R. Actually, that would look a little nicer if we said there exists a value R, where R is between 1 and 3, such that h of r equals -5. Okay, so another example, I wanted to go over some composite ones with you, and this leads to the next one. Okay, this says if g is continuous, so I'm looking at this, it's in a box, so it's something we want to know. If g is continuous and f is continuous, then when you take the composite function, you get continuity. That's all that is saying. Okay, so just a little side note as we look at this. This next example is just a review of continuity. So we finished the lesson for today. So I just wanted to go over an example. Maybe there's something like this in your homework, or maybe I just thought it was kind of important. Okay, so we want to find a, so we're asking to find a such that the function is continuous on this number line. So what does it mean to be continuous? It means that the limit equals the output. So the limit as x approaches a of g of x equals g of a. So we want this to happen. So remember, this is the kind of piecewise, we had two different piecewise, where you actually have this ordered pair over here of A8, and everywhere else you use the top function. Okay, so let's start dealing with the limit We already know what g of a is. Isn't g of a 8? They tell us that. So let's start finding the limit. Remember, on these problems, you're trying to find these a values over here such that when you plug them in, you get a continuous function. Okay, so what we're going to do here is let's replace a with what g is, which is x minus a, x plus a, all over x minus a. And this has to equal g of a, which is 8. I mentioned over here that we already know that value. So now we're just solving this for a, so it's a little backwards. If I try subbing a in, I'm going to get 0 over 0. You guys remember that that's indeterminate, which means more work. The first thing is factor, which I kind of just did instinctively. Did you see the x minus a's cancel? So now I no longer have that 0 on the bottom, so I can work through this. If you replace x with a, I'm going to get a plus a equals 8. 2a is 8. You're probably already thinking quicker than me, and a is 4. Find a such that the function is continuous. So now when I replace this a in the problem with 4, I'm going to get a function that's continuous. If a is anything other than 4, that's not going to work. Okay, so just to review on that one, that's a wrap on 1.4. See you guys.